Hello students, let us discuss the reactivity with hydrogen for group 16 elements. These elements are oxygen, sulfur, selenium, tellurium, polonium. All these elements form hydride, that is of type H2e. That is, here E is representing the group 16 element, that is, the compounds are in this way, the hydrides H2o, H2s, H2Se, H2Te, H2PO. These are the hydrides of group 16. Let us discuss the structure for these hydrides. They have angular structure which involves sp3 hybridization of the central atom. For example, the structure of water is familiar to you, in which the central atom is oxygen in the case of water, which is sp3 hybridized. Here there are two bond pairs and two lone pairs. Because of the lone pair repulsion, which is greater than the lone pair bond pair repulsion, which is greater than bond pair repulsion, the angle here it is 104.5 degree. So all these hydrides have a similar type of structure, that is a bend shape, but the geometry is tetrahedral. So when we make the structure for all these, it will be in this way. As we know that when the size of the atom increases, the bond length also increases. So when you compare the OH bond in the water and when it is compared with the SH bond in H2S, so definitely because the size of S is greater than O, so the bond length is greater. So what we can say that when the size of the central atom increases top to bottom, the bond length is increasing. So when the bond length is greater, it will be easy to break the bond, so the H will be given out very easily. So we can say that greater will be the acidic. So when we compare the acidic character of H2O with H2Te, it is found that it is more acidic because of the greater bond length, easy to break, gives H plus sign easily, therefore it is more acidic. And we can say that it is the more unstable one, and this is water is the more stable one. So it have a greater reducing power also because of it can give H easily. So when we compare the table which is given in the textbook, it shows that for H2O, H2S, H2SC and H2Te, as top to bottom the size of the central atom is increasing, so that is the bond length is increasing. So when you check the value here, the bond length is given in picometer 96, it is given for H2O, then for H2S 134, 146 for H2SE and 169 for H2Te. This value shows that the bond length is increasing because the size of the central atom is increasing here. Therefore, bond length is increasing. So, greater the bond length, easy to break the bond. So, that means less amount of energy is required. So, when we check the bond dissociation enthalpy value which is given here, it is clear that for H2Te, the bond dissociation enthalpy is less in compared to the others. That is also the reason is same reason here. So, because of this reason, in the case of H2Te, less energy is required to break the bond, therefore it gives H plus easily. So it is more acidic and unstable among all the others, and it have a greater reducing character. So what we can say that among the hydrides here, H2O is liquid, others are colorless, foul smelling gases. So why H2O is liquid? Because there is a intermolecular hydrogen bond exist, but in the case of other molecules it does not exist. As the bond length is increases down the group, so we can say that the bond dissociation enthalpy, that is, decreases down the group. So when you compare the acidic strength, it is in this order. That means the element which is bottom to the group that form the hydride which is more acidic, and when you compare the reducing character also, it will be in the same way as like the acidic character, but the thermal stability is inverse of the acidic strength. Why? Because which is a more stable does not undergoes the cleavage of the bond very easily, but which is unstable, that is actually the bond cleavage is taking place easily. In the textbook, some of the questions are related to this concept. So let us discuss that. First question, H2S is less acidic than H2TE. Why? Because the answer is given already in the textbook. Because just now we have discussed that greater the size of the central atom, greater will be the bond length, easy to break. So when we make the structure for H2S and H2TE, it will be in this way. Here the bond length is greater, so easy to break. So we can say that it gives this H easily. So due to the decrease in the bond dissociation enthalpy down the group, acidic character increases. That is the answer for this. Next question. List some important sources of sulfur that you can easily find from the textbook. From where are the important sources of sulfur? That is the H2S gas that is released from volcanoes, that is, and other some examples are also there. Write the order of thermal stability of hydride of group 16 element. Thermal stability, just now we have discussed, which is more acidic than in which the bond cleavage takes place easily, that is more acidic, that is a more unstable one. So which one will be the more stable? That is water. Water is more stable here. Then the stability is actually decreases down the group. So the reason is same reason which we have discussed, that is greater the size of the central atom, greater will be the bond length, easy to break, therefore greater unstable. Next question, why H2O is a liquid and H2S is a gas? Because both are the hydrides of group 16, that is oxygen and sulfur are both the members of group 16, but still one is liquid, the other one is gas. So what is the reason for this one? That is intermolecular hydrogen bond which is present in between the water molecules. Since oxygen is more electronegative, therefore it can form hydrogen bond, but S, sulfur, does not form hydrogen bond, so definitely the particles will be closer, therefore they are the liquid in nature. So these are the some questions related to this concept. So this is all about this video. Have a nice day.